So hi everyone. Today we'll try to understand why naive Bayes method model is called as a generative model and not a discriminative model. So as you know that we have two types of model. One is generative and other are discriminative. So discriminative models basically tries to discriminate between different classes without understanding the distribution. While in case of generative model, the generative model tries to understand the distribution of the data set irrespective of the multiple classes present in it. So they try to understand the model distribution of the data set and then hence can be used to generate new data sets as well. So as you must, I think this is a common interview question that why naive Bayes is generative model and not a discriminative model. So let's find out by going through a particular example. Assume that you are an Instagram model. You got yourself clicked in the below attires. There are different pictures of you like with pink hair, pink dress, white dress, blue tops, gray jeans, etc. Now you have already tried out many attires for yourself. You're planning to have a different combination for your next, but now as of now you can't think of which attire you should go next with. So assume that these are the possible options. You have seven different hairstyles, six different hair colors, three types of glasses, four kind of clothes, and four different clothing colors as well. Right. That means that we can have a total of 4032 unique combinations. Also there is one more point that wish to figure out is that there is a probability of choosing a few things in particular categories are very high as compared to other other props in that same category. For example, you prefer silver gray curly hair over others, similarly white tops over green tops. So there are two things. One is that the possible combinations that you have. Second, say this possible attire, the items that you have that you can wear. Second thing is that you also prefer a certain elements from different categories, right? Now this the second point mathematically, like you having a preference for some items, mathematically means that the distribution of selection, the probability of selection of all the elements is not uniform. So clothing your top with green color will have should have a lower probability as compared to your top with white color, as you say that key white tops are preferred over green tops. This makes sense, right? Hence the probability distribution is not uniform. This is one point that we should remember. Wish to calculate the probability for any particular attire, we should calculate the frequency of the attire coming in upon total number of samples, right? So this is the basic mathematics that we follow. So for example, if I wish to calculate the probability for red and round top plus white hair plus no glasses is equals to 4 upon 100, because 100 is the total attires that you can have, total samples that you have, total images, and 4 is the combination, 4 is this particular combination is coming 4 times in this 100 attires, right? Now a big limitation by calculating probability in this way. So usually we calculate probability like this: frequency upon total number of samples we have. So 100 samples we have. Assume that you have 100 images right now, and out of those 100 images, you have wore this particular combination 4 times. Now for unseen combinations, this will give you a probability 0. Now this can again be solved by using some sort of a constant for unseen combinations. Now, but you have missed out on a point, right? So if you remember, we have a strong craving for silver hairs and white tops, right? Now assume that you don't have you're trying out a new attire which includes white tops now, right? But as I told you that as we haven't seen that combination, the probability if we calculate using this method would be 0, because this particular combination, assume that green white top with some round glasses with pink hair, is a combination that you have never tried out, but there is one element that you prefer from this combination, that is white hair. Hence its probability should be greater than the probability of some random combination, right? Because there is an element of preference from your end. But this is not happening here because first of all, as a combination has not been tried yet, that is the probability will become 0. Even if we add a constant key, okay, see, for any combination that is not seen, we are giving it a probability of k, but the k would be equal for any other random combination as well. So actually what should happen is that we should be able to give preference of this new combination which includes an element of favor as compared to any random combination, right? So the model should assign a higher probability to some unseen combination than others which have the preferred element, as I gave you the example. And also as I told you that key, even if certain combinations have elements of preference by the above method, we would be getting a probability same as some random method, that is either 0 or k. So the problem is that we are assuming every element to be dependent on each other. That is the probability of having probability a comma b comma c comma d comma e. That means these are the 5 categories that we have. the probability is equals to A intersection B intersection C intersection D intersection E intersection, right? Should this be the case? And that is why we are having a constant or zero probability if any of the element is not seen, right? So assume that in this five items that you're wearing, four are from your preference, but one you haven't wear ever. So in that case, this combination is never seen, and hence the probability sign is 0 or k. This shouldn't be happening. So how to assign a higher probability to such combinations where there are elements of interest present given the data set? So instead of using this intersection, we can go for multiplication. So the probability of a comma b comma c comma d comma e can be given a probability of a into probability of b into probability of c probability of d probability of e, right? So in this case, if you understand, like for example, if we take black hair, long curly hair, pink top, round top, no glasses, so the probability would be given by each element's probability independent of each other. Try remembering the properties of naive bias. So in naive bias also we assume that the elements, the different features are independent of each other, right? So this the same concept is coming here. The each feature is independent of each other, and the probabilities are getting multiplied rather than we are trying to figure out the probability for the whole combination at once, where the probability of one element can be calculated by frequency of black hair upon total in some image, that is 100. So now you understand that how naive bias. So this is the idea from which naive bias takes an inspiration from. The ideology remains the same. So if you remember again, it also assumed that all the features present in a data set are independent of each other, and it is a generative model because, as you understand, it is trying to understand the distribution of the data set, right? And eventually, it is able to provide higher frequency for more probable combinations that would be successful as compared to combinations that won't be that successful, right? And it is not a discriminative model because it is not trying to discriminate between different classes, but it is trying to learn the distribution as a whole.